In this video, I want to talk a little bit about metric micrometers. Here is a metric micrometer. Now, before I talk about the micrometer itself, I want to go back a little bit and talk about the steel rule. Now, this steel rule right here, well, this is in inches. I'm interested in the metric system right now, so I'm going to flip this over and look at the metric side of this steel rule. And on this scale on the top, the discrimination is 1 millimeter. So each one of these lines has a separation of 1 millimeter. And if I wanted a higher discrimination or more finer discrimination, I can go to this scale down here, which is in half millimeters. So the discrimination here is half a millimeter. And if I'm put this rule down here, and on this page, I'm going to just simply try and draw 1 millimeter between two lines. So let's choose between 60 and 61. So between here and here, that gap is 1 millimeter. I'm going to write it up here, 1 millimeter. If I wanted to divide this 1 millimeter by 10, so put in 10 little lines in between that 1 millimeter, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I put in 10 lines. Now you can't see those 10 lines. Mathematically, the distance between the individual lines, which I have just added between that 1 millimeter, if I divide that by 10, because I have separated or divided into 10 separate segments, that will be equal to 0.1 millimeters. So each one of these lines, which we cannot see visually, is now 0.1 millimeters. Now imagine I take that 0.1 millimeters and section it into 10 little more spaces again. So divide this by 10 one more time. And then each little line, even though I can't see it and I can't physically do it here, would represent 0.01 millimeters. So the discrimination here is 0.1 millimeters and discrimination there is 0.01 millimeters. Cannot do that with a rule. The best the rule can do is either the 1 millimeter, and you can see here the 1 millimeter, or better yet, it goes down to the half millimeter, 0.5 of a millimeter. So each line then represents 0.5 millimeters. But if I wanted to measure something more fine, more precise than just 0.5, say I wanted to measure something to 0.1 millimeters or 0.01 millimeters, I cannot use the rule. And that's where the micrometer comes in. And let's take another closer look at this micrometer. This one here is the metric micrometer. There is a scale here. This is called the barrel. Sometimes this is called the sleeve right here. I'm going to open up the thimble and expose the graduations on the sleeve. You gotta forgive my lighting. It's not very good. I'm trying to show you these lines in here. What this is right here, in fact, is a rule. Yeah, try and show it this way. I'm going to bring it up closer to the camera. This right here is, in fact, a rule. The top lines are separated by 1 millimeter. Those are all 1 millimeter apart. If I were to take my rule with the 1 millimeters, they will line up. There's going to be some parallax involved here. I'm going to try and do this. See, all of the lines here, there we go, will line up to 1 millimeter. On the bottom is the half millimeters. So here is 0, half a millimeter, 1 millimeter, 1.5, 2, 2.5. That would be the bottom rule right here at the half millimeter discrimination. So if I were to try and line this up showing both top and bottom, you'll notice that this scale here on the barrel is in fact a rule, and it has a discrimination of half a millimeter. These will line up. It is in fact a rule. If you look at the number 10 on here, look at the number 10 here, they will line up as best as I can do it here freehand. And if I try and get the half millimeter in here as well, apologize for all the focusing and stuff that's happening here. My hand's going up and down. But I think you get the idea. that this is inscribed here on the barrel is in fact a rule. So I can use this as a rule, no different than this one. It just happens to be on a barrel. So here's the rule, and this micrometer is based on this rule. Difference is it has some attachments to it. These attachments are put on here in order for us to get a thing called amplification. And that amplification allows us to have this micrometer go down to 0.1 millimeter measurement and as far down as to 0.01 millimeters. And that is done by using a thread screw. And that concept is called amplification. Amplification. And this is a mechanical means of making something small appear big. Appear. Not really make it big, but appear bigger. And this is done using a thread screw. Another way to make things appear bigger is magnification. And this is done through lenses. My camera has a lens right now, and I have it set at 1.5 times magnification, such that everything you see here is 1.5 times bigger than it is in real life. That's what I have that camera set to, 1.5 times magnification. And this micrometer right here has a thing called amplification done to it, and it's done through a thread screw. Thread screw. And that is in the inside of this. I'm going to show it to you. I have an older, well, really older micrometer right here. I think I left this in my garage a few winters, too many. Even squeaks. A few things don't work on it. Nevertheless, I'm going to take this apart. I can do this to this really old mic. I don't want to do it to one of my newer ones. I take this apart. You see, as I'm rotating this, it's exactly like a screw. I want to take apart a screw. Here we go. In here, there is a thread. It's difficult to see with the lighting I have here. There it is. On the inside, there is a thread. You can see it better here. And there it is. There's the thread screw right here. Oops. Right there. See these threads? These threads here are designed in such a way to give us amplification. For a metric micrometer, the thread screw, the pitch on this thread screw here is 0.5 millimeters. And for an imperial micrometer, the thread here is set up at 40 threads per inch in order to give us amplification. And in our case, we want to amplify 1 millimeter. We want to be able to see 0.1 millimeters and 0.01 millimeters by using this thread screw to that specific size. This here is the thimble, and here is the spindle, and the two are connected. I'm going to put this back together again into the frame. All right. So my lock here, the little clamp ring is broken. I just have to get it past it and start connecting the threads again. I don't recommend you do this to a new micrometer. Sometimes I get this to work, and other times when I most want it to work, well, you know, it just doesn't want to cooperate. There we go. Now it's back on there. Okay. So as I rotate the thimble, it moves up that thread screw, and it pushes the spindle here outward. And this is where the actual measurement is done. The part is positioned here. This is the gap I want to measure, but the actual reading is done here where the graduations are. And this is where the amplification is also happening. So that's the old one. Let's go back to the new one. Here we go. So here is the spindle. Oh, let's do one more step. Here we go. Here's a very good metrology book. Inside in this book right here, has the various names of the various parts of a micrometer. Let me just close this up a little bit more so you can see it better. And up here at the top is a ratchet stop. Here is the ratchet stop. And that's there such that whenever I have an object here and I use the ratchet stop, it will always govern the same amount of torque. So I don't over tighten the part. That's what this ratchet stop here will do. You can hear it clicking. So we have a ratchet stop so you don't over tighten. And this is the thimble. Here's the thimble scale. This is where the amplification is being shown right here, this thimble scale. I'll show you that in a few minutes. And we have the barrel and the barrel scale. And that barrel scale, as I said earlier, is an actual rule. This is 1-to-1 ratio with a rule, 1 millimeter, 2 millimeters, half millimeters, etc. Here's the barrel. The barrel is also called a sleeve. And we have the clamp ring. There's different different designs for clamping. And here's another one. Here's a little lever for clamping using this lever. Same idea. They both do the same function. They just simply clamp the sleeve here from moving. I mean the spindle from moving. And we have the spindle. We have an anvil at the bottom right there. And the frame itself. Going back to where I was earlier, amplification. The standard rule can only resolve, or we are able to see with our physical eyes, about half a millimeter. If you want to go something smaller, the 0.1 and 0.01, that's where this comes in. So this is nothing more than a fancy rule. Here's the rule portion right here, that scale, that's the rule. And all these other attachments right here, they're here in order to give us this little thing called amplification. And the 0.01, let's start with the 0.01. If we go to the thimble, and on the thimble there are graduations. Try this way. Each one of these graduations on the thimble right here, it represents the 0.01 millimeters. Now the actual distance is not from here to there 0.01. This is being amplified. The actual distance of 0.01 millimeters will be here. So let's do that. I'm going to close this up to 0. So it's now at 0. You can see here at 0. And if I open up to the very first line, I have now moved the spindle a distance of 0.01 millimeters. And clearly, this is where the actual reading is. You can't see the gap. 0.01, it's very, very small. So if that first line is 0.01, the second line then will make it 0.02, 0.03, 0.04, 0.05, 0.06, 07, 08, 09, 0.1. So here's the 0. Everything here is closed. And I'm going to open this up to 0.1. This will represent 0.1. You have to imagine there's always a decimal point in front of this. In front of the 5 will be a 0, or 0.05. This will be 0.1, 0.15, 0.220. So I'm now at 0.1 millimeters. Here we are, 0.1 millimeters. So this will allow me to visually see 0.1 millimeters on the thimble. And it's the distance between here and here, so I can readily see it. But the actual 0.1 millimeters is here. You can see that little light. That is, in fact, 0.1 millimeters. That gap in there is 0.1. I'm going to open this up here to 0.5 millimeters because that's the resolution or the discrimination of the steel rule. There's 0.1, 0.2, 0.3, 0.4. 0.5 millimeters. Now this gap here represents I should say 0.5 millimeters. It's represented on an amplification basis here on the thimble by the one complete rotation. All of that would represent this distance of 0.1 millimeters, and in that case I'm sure 0.5 millimeters, my mistake, 0.5. So if I were to measure that gap and represent it with a rule, that gap in here is in fact 0.5 millimeters. 0.5 millimeters. So that's easier enough to see here, that 0.5, but amplification allows me to use this thimble such that one full rotation of this thimble would represent 0.5 millimeters. And each one of these lines represents 0.01, and a distance between, let's say, the 40 and, well, let me go down here. The 30 and the 40, this is 0.3 to 0.4, is a distance of 0.1 millimeters. Translational 0.1 millimeters here. So this micrometer will allow us, via amplification, to measure items as low as 0.1 millimeters and as low as, or further down, to 0.01 millimeters. This will be the discrimination of this micrometer. 0.01 millimeters is the finest that it will be able to measure thanks to a thing called amplification. And that's what these graduations are on the thimble here. They represent 0.01 millimeters. And this is a basic introduction to the metric micrometer, and it is directly related to a scale.